I recently saw a slide from the FAA Beyond 2 program offering that autonomy means no possibility of operator intervention. And that aligns with the ARC report recommendation. There's a table in there that talks about AFR levels, or automated flight rules levels, where level 4 is human out of the loop with no possibility of human intervention, and AFR 3 is human over the loop, also called fully or highly automated, where human intervention is possible but not required. And if that's how we're going to define it, then great, there's plenty of room for expansion and innovation with highly automated systems. So if operator intervention only boils down to a big red stop button, I think it's kind of a distinction without a difference. And again, it's a good thing as long as we remember that we don't over tilt on the safety benefit of direct human oversight. So no matter what we call it, what I'm interested in is unleashing certain operations from real-time direct supervision by a remote pilot or trained operator. And to be a little provocative, I call this zero to many.
Welcome to The Vertical Space, the podcast at the intersection of technology and flight, featuring deep dives with innovators, early adopters, and industry leaders. We are your hosts, Jim Barry from Celerity 05 and Peter Shannon and Luka Tomjanovich from Radius Capital. At Celerity 05, we believe that breakthrough air transportation capabilities come from leveraging current and emerging technologies, and that companies achieve profitability through relevant technologies, strong teams, and a deep understanding of the aviation market. Connect with global aviation experts at celerity05.com for feedback and recommendations to chart your path to success. At Radius Capital, we invest in early-stage deep tech that redefines what is possible in aerospace. We partner with founders building next-generation aerospace capabilities, from advanced design and development tools to the digital transformation of the flight environment, novel use cases and forms of flight, and the software and systems that make them possible. If this describes you, reach out. We're excited to connect. All right, let's dive in.
Hey everyone, welcome back to The Vertical Space. In today's episode, which features insightful conversation with Jenn Player, Vice President of Global Aviation Regulatory Affairs at Skydio and a leading voice in the drone industry. We kick things off by exploring why electronic conspicuity could be the silver bullet for creating a fully cooperative shared airspace. It's a fascinating and somewhat controversial discussion, touching on detect and avoid technologies, technical standards, and limitations. Jenn shares her experience flying larger UAS in controlled airspace with the U.S. Air Force Research Lab and BNSF, where despite meaningful flight experience and comprehensive equipage with ADS-B, VHF radios, transponders, and other technologies, detect and avoid remained a persistent challenge. This realization led Jenn to pivot towards smaller, highly automated, and cost-effective drones operating close to the ground and obstacles, and her joining Skydio to Unlocking the Dock. So we dive deep into drone docks, their value proposition, evolution, use cases, and the drone-in-a-box value chain. Jenn breaks down how they're operationalized, from safe drone operations to data integrations. As the episode title suggests, much of our discussion centers on autonomous operations and the nuanced difference between autonomous and highly automated systems. Jenn introduces a provocative vision of zero-to-many operations, moving away from the traditional model of operators monitoring flights like air traffic controllers. Instead, she envisions a future where humans are only involved when something abnormal happens, leaving the highly automated drones to handle the missions independently. It's a practical and achievable shift that could redefine how we think about drone operations. We also touch on the state of the drone market, both defense and civil commercial, and why the civil commercial segment still feels like it's in its early days. Finally, we wrap up with some forward-look insights and advice for entrepreneurs navigating this space. At Skydio, Jenn collaborates with customers, regulators, and standards development organizations to advance autonomy and beyond visual line-of-sight operations. She participates in international technical standards development and advisory work groups on detect and avoid technology, remote ID, airworthiness, and autonomy. She served as an industry working group lead on the FAA's UAS BVLOS Aviation Rulemaking Committee and also participated in the FAA UAS Detection and Mitigation Rulemaking Committee. Jenn has over 20 years of aviation industry experience with technical roles at the U.S. Naval Air Systems Command, Burrell Applied Research, Cessna, and NASA Langley. She has more than 10 years of experience in uncrewed aircraft systems research, testing, and operations. Her earlier work to integrate drones into the National Airspace System through the FAA's Pathfinder program with BNSF Railway led to the first long-range BVLOS civil flight in the continental United States in 2016, the first national-scale approval for Class G airspace in 2019, and the first approval for shielded operations applicable to drone-in-a-box solutions in 2021. Prior to joining Skydio, Jenn founded Avenir, a consulting firm helping manufacturers in the drone delivery space navigate the type certification process and helping enterprises gain approvals for BVLOS and other complex operations. Jenn received her Bachelor of Science degree in Aerospace Engineering from the Pennsylvania State University. She holds an FAA Remote Pilot Certificate and a Private Pilot Certificate with ratings in single-engine airplanes and gliders. Many thanks to Jenn for a great conversation.
This episode of the Vertical Space podcast is brought to you by Avionics. Avionics is the leader in low size, weight, and power certified avionics for manned, unmanned, and advanced air mobility aircraft. Let Avionics help you achieve your goals, whether that be type certification, airspace access, or beyond visual line of sight operations. Avionics has certified and certifiable communications, navigation, and surveillance avionics for your aircraft. So head over to uavionics.com or Google it to see how you can start flying safer and move your platform forward into shared airspace. Jenn, welcome to the Vertical Space. It's a real pleasure to have you on the show.
Yeah, thanks for inviting me. It's an honor and a pleasure to have this conversation. I'm looking forward to it.
Likewise. So we start by asking if there's anything that very few in the industry agree with you on.
Well, let's tackle that. Last spring, I participated in a panel called Electronic Conspicuity. Is it the silver bullet for airspace integration? And my answer was yes, and I might have been the only participant to say that out loud. In my opinion, see and avoid has been the number one technical and regulatory challenge for the drone industry. And I spent 5 years of my professional life testing and evaluating a variety of detect and avoid solutions. And really, most of the time, that was only focused on that first step, detection, radars, cameras, acoustics, onboard the drone and ground base. And it's just a hard problem, simply due to the performance and maneuvering disadvantage of most drones, which are flying slower than most traditional aircraft. And then requiring the end-to-end performance of that system to be far, far superior to that of a human in a cockpit also adds to that challenge. So from a technical perspective, the most tractable and straightforward answer is to have a more collaborative, if not fully cooperative, shared airspace. In my mind, ideally, that's one where everyone has a relatively inexpensive transponder on board, that aircraft communicate to each other, enough anonymized trajectory information to facilitate strategic deconfliction and possibly even tactical collision avoidance. So I'm really not sure if there's broad disagreement about the technical merits, the cost efficiency of that type of solution. But I think there's probably a sense that it's impossible, that there are too many barriers to implementation and adoption. So I think it's not talked about enough, maybe, as a solution to go forward. And so I don't know if it's disagreement, but just maybe no one's talking about it as much as I wish we would. But the lack of forward progress on DAA is really what led to my interest in very small autonomous drones and drone-in-a-box solutions.
What's your idea of a good implementation of conspicuity?
Well, I think I mentioned a few things, right? Electronic conspicuity being some means of radios talking to each other, right? So you can adjust power in accordance with what's needed where. You can be anonymous, so you're not necessarily in a traffic management situation, but in a vehicle-to-vehicle sense, you can exchange enough information to avoid each other either strategically or tactically, depending on the performance of such a system. So I think a world in which we all had this technology aboard our aircraft, that it was, I think it's a relatively cost-effective thing to do. I think that the technologies, there's always challenges with spectrum, but I think it's a tractable thing to do, would really kind of open up the airspace for everyone.
What do you think has been holding the DAA progress? Obviously, there's technological issues, swap and cost, and on the ground infrastructure side, lots of capital investments to create the necessary coverage. But what are some of the finer points to this lack of progress that we're seeing?
Well, one thing is what's good enough. And there hasn't been an accepted technical standard that everyone can use to, and it's not in a form where you can really use it to put the whole system together and know what you're going to get at the end, which makes it hard. So not knowing which target you're trying to reach from a safety perspective is hard. And then there's just the physics side of how far away do I need to detect a target so that the least maneuverable aircraft in the sky can get out of the way of that more maneuverable higher performance vehicle. So you have to detect fairly far out, and so for smaller drones that definitely becomes a swap problem. So I don't think it's any one thing. I think it all boils down to having to do a detection, having the UAS have to be the one to get out of the way, and having UAS mean a variety of different aircraft configurations. It could be a helicopter or multi-rotor. It could be a blimp, and it has to get out of the way of all other, air traffic, person-carrying aircraft. So it's just a hard problem on multiple fronts. But I think that the biggest thing is not knowing the target that we're trying to reach and not having technical standards that can get us there.
Jen, has anyone or any one location throughout the world, are they closer to your vision than anyone else?
I'm not really sure. The more cooperative an airspace is, or the more segregated it is, I suppose it would be easier to integrate drones, but I don't know that I have the knowledge to answer that question.
In the community, what are the objections to the ideas that you're putting forward, and what's the reasoning behind those counterpoints?
There are a variety of counterpoints. One is equipage for all, right? The burden's been put on new entrants, so drones in the AAM world, to solve this problem because there's no human on board to see. The rule says see and avoid. The larger the aircraft, right, probably will find an onboard solution that works because swap is an issue here. But for smaller drones, it's really a challenge. And so what we have to do is find an interoperability solution that everyone can live with, or find a technical solution that's cost efficient enough for everyone to adopt it. But there are incumbents who, attract a lot of attention as to not wanting to equip. And I think it would be wonderful for voluntary equipage to happen. I think we might get there. So ADS-B, for example, right? Not everyone has to equip with ADS-B. It's a pretty good idea. The costs have come down and down and down over the years. You have to buy the equipment and you have to install it in your aircraft. Some aircraft don't have electrical systems, so we often talk about balloons or gliders or ultralights not having to have these things, and maybe it's really hard for them to have a transponder-like solution. I don't really think that's the case. I think there are ways to open up the technology solution to be inclusive of portable devices, of low power devices, of things like inert and alert, where you don't crowd the traditional aviation screen with a bunch of drones unless they're actually nearby. So I think there's creative space in the collaborative, cooperative, conspicuity world that hasn't been really truly explored yet, mostly because I think some people just don't feel like it's their responsibility to participate in that.
Well, I mean, some of the reasons behind the objections for equipage, one would certainly be cost and interruption of ongoing operations to actually do the equipage. But the other side of it is that ADS-B is not anonymous. And not only is it a unique identifier for the aircraft that is being broadcast, but it's a unique identifier that can be looked up by anybody in the world right on the front page of the FAA website. For a little bit of background, why is that the case even today? Why was ADS-B made so transparent versus anonymous? And looking ahead, I mean, if that's one of the big areas of objection and what we're talking about, we don't care about the identifier of the aircraft that we're trying to avoid. We just want to avoid the object. So help me understand the background on that issue.
Well, I assume that it's because it's used for air traffic management, or that was the intent. And so if you're going to see an aircraft on a scope and you're going to talk to it from an air traffic control perspective, you need the N number. And maybe for validation reasons, you need the ICAO number of the transponder. So I'm maybe not the most knowledgeable on the origins of that, but I totally agree that In terms of what I think of as e-conspicuity, we don't necessarily need to have any of that information, and it could be anonymized. It should be anonymized, especially when you're not participating in air traffic management. So, what I'm speaking to is the below 400 foot type of airspace where smaller drones are operating in the scope of Part 108.
Completely. I agree. I mean, I think we're really holding ourselves back because of this issue with ADSB. If we could get around that, if we could create a technical solution that gets around that for this purpose, we would all be in a better place.
Yeah, and all I'm trying to point out is that, yes, there are still technical challenges to be overcome, even with e-conspicuity, or if ADSB is used as e-conspicuity, but those would present themselves as being non-technical challenges to overcome. Like there's still some technical challenges, but the big hurdle has just been adoption, implementation, and the will to tackle some of the aspects of it.
Jen, how do you think that this will get addressed in the Part 108 regulations? Do you expect the FAA will try to bypass the problem with shielding and UTM-like implementations, or do you think there will be some concrete measures on perhaps mandating some kind of e-conspicuity?
Well, I can speak to what was in the recommendations in the ARC report. And what was recommended was that if an aircraft operating below 400 feet, a person-carrying aircraft, is equipped with ADSB out, the assumption being that drones will have ADSB in, you detect the aircraft with ADSB out, and you yield the right-of-way. So the drone's yielding the right-of-way to all the aircraft that are equipped. But should an aircraft choose to not equip and fly below 400 feet, then they are assuming risk. So the drone can't detect them, and there may be a collision, but the person carrying aircraft took on that risk in order to share the airspace. That's provocative, but that's what was proposed. And the impetus there is, if you don't think there are any drones around where you're flying, go ahead and fly. You don't have to equip. There's not going to be a mandate, but you're taking on risk of collision. And if you equip and the drone doesn't yield the right of way and there's a collision, then the responsibility would be on the drone. We have indications that something like that will appear in the NPRM. I think a lot of people are assuming that there'll be pushback to that in the public comment period.
Great. Okay, so how does this lead to the concept of the drone in the box?
Right. So I came to drones from traditional aviation, and my first UAS project was building a 300-pound demonstrator for Air Force Research Lab and figuring out how to get a clearance to fly it in restricted airspace. Then I went from that and supported BNSF Railway under the FAA Pathfinder 3 program, where in the span of only a few years, we were flying a 110-pound drone for 4 to 6 hours a day, generally covering more than 100 miles per flight. And our mindset was to fly that drone like it was any other aircraft. We had ADSB out, transponder. We had VHF radio relay. We could squawk. We could talk. We even developed procedures for transiting in a Class Delta airspace. We were talking to the controllers on the radio. They could see our drone on secondary radar, just like any other aircraft. And we were consistently flying. In fact, we accumulated, I think it was like more than 23,000 track miles of BVLOS flight over a couple of years. So honestly, things worked really well from that perspective. But throughout, we were trying a variety of DAA solutions. And to be clear, we were flying directly over railroad tracks in very rural parts of New Mexico and Montana. So the ground risk was very low, and the estimated likelihood of encounter with another aircraft was also very low. But if you're going to have an encounter with an aircraft in those environments, it's more likely to be non-cooperative versus if you're, say, flying in the mode CVL, where the equipage is required, you're likely going to encounter a cooperative aircraft. So all the struggles with finding a DAA solution, it just seemed like we didn't have a path forward. The FAA was a great partner throughout all this. We secured numerous approvals to try things and to keep flying in these low-risk areas, but I finally got the sense that we were just really maybe too early to scale that kind of a long linear operation with a larger UAS. So that led to a mindset pivot. What's the lowest risk thing we can do that's actually scalable in the near term and can provide value? So mostly a drone is a method of positioning a camera or another sensor in 3D space. That's the value it brings. It's the information. The drone's a truck positioning a camera. So you can do that with a few big drones with very expensive cameras and gimbal systems, and sometimes, even often, you can do it, better with a smaller drone and a less expensive camera. So it seemed pretty clear that like the best path in the near term was distribution of very small, highly automated, less costly drones operated close to the ground and obstacles where the likelihood of encounter with a person carrying aircraft is just practically zero. So the air risk is strategically deconflicted, and DAA, if you have it, doesn't even offer a significant safety benefit. So that's where the shielding comes from. Now, if you're going to fly low and close to obstacles that are, the obstacles to air navigation for most aircraft, and you don't want to collide with those obstacles, trade ground risk for the air risk savings. So that's what made Skydio so compelling, and that's why I joined the company. It just seemed like, hey, here's a complete solution. They have the obstacle avoidance system through computer vision. It's a small drone. It's got a good camera on it. We can put a lot of them out there, fly them remotely, increase the autonomy level, and still get good value, and collect a lot of information.
What do you think is a trade-off in that particular example between using small drones with less sophisticated payloads, arguably, versus having a more complex aircraft with more sophisticated payloads, but you get to cover a lot more space with it? It is an interesting trade space, and how does a customer look at it and make the decision?
Right. I do think, there are use cases that probably don't make sense for drone in a box. It's maybe not the best solution for long linear if your objective is to, cover large distances very frequently, something like pipelines or railroad tracks, things of that nature. You'd have to put a lot of docked drones out in the world to do that. But in other cases, for example, where there's an area or a facility, kind of a problem area, a hotspot, where it's remotely located or it's something you're going to do frequently, and you kind of know, like, I'm going to fly this drone here, I'm going to take this data every day, or I'm going to take it every week, and this is the spot I'm interested in, then that's where you can distribute a drone. So if you trade off long linear, I'm going to look at every inch of railroad track for 100 miles, for example. Probably want a bigger drone that flies relatively fast, can fly for hours on end, and can use the same sensor to collect the same type of data in a consistent manner, so you can do change detection, things like that. But if you're looking for a specific kind of fault or failure in a component, and you've got a problem with it, for example, you want to keep eyes on it, and you don't need to look at every inch of your infrastructure every day, then you can easily do that with a drone in a box solution.
So since you joined Skydio, what has been the evolution of drone docks in terms of their sophistication, their cost, and importantly, customer adoption?
Yeah, we're seeing adoption. We're all in on docked drones or drone in a box solution. Again, I think it's this compelling case of using small drones. It's a matter of perspective, right? Some small drones compared to other small drones seem like they're more costly. But if you compare that to very large, sophisticated aircraft, they're not that costly. And then you have to figure out, well, how many do I need? And what value am I going to get covering an area, a facility, a city, for example, a highway, whatever it is? How many dock drones am I going to deploy to get the information I need, to get the coverage I need? And I think it's fewer than you might think. Maybe 100 dock drones across an entire city, meeting a whole variety of use cases, and the cost of that and the utility of it, you just wouldn't compare it to, say, flying overhead with a more expensive, larger aircraft. You probably just wouldn't even do that. So I think docked drones unlock use cases all the time that are super compelling, and drone as first responder is one of those, smart city applications, disaster response. Being able to deploy a drone quickly, save in the case of utilities, right, saving a truck roll. If you have a docked drone remotely located in a place where you would normally have to roll a truck, wake a person up, send them in a truck for miles to have them go look at something and then make an assessment on what needs to happen next. You have the drone there to go look at things, to be controlled remotely, or to automatically go look at something, be able to provide information that helps you assess it, and then send whatever help is needed, whatever remedy is required. Those savings, by having that deployed infrastructure, I think are very clear, and I think we're going to see more and more adoption of that. One of the things that's going to unlock that is a regulatory framework that makes it easier to scale these things, right? The pathway is there are no blockers. Now it's about finding the right use case match and then going out and deploying the hardware.
Who have been the most aggressive users of dock drones over the last couple of years? And what really are the aspects of the docks that they have most pain with? Obviously, cost is one. We've seen costs come down from 300,000, 400,000 4 or 5 years ago to 15,000. So that seems like it's one of those dimensions that's solved for most customers. But what are some of the others?
Well, I mean, you need backhaul to the system, and you need to move that data around. And so, deploying docked drones, it is installing infrastructure, and that's one of the things we've noticed that maybe is harder for customers to do on their own. So at Skydio, we help with all of that. We take a part in going to a customer's location and helping them install that equipment and making sure it's all connected and working and ready to go for them to use. Because it's more sophisticated than, pulling a drone out of a case, putting a battery in it, turning the controller on, and then flying it around in front of you. There's more to it than that. So I think we've gotten smarter about the fact that customers need help with this. We provide that help. We get them up and running so that they're just worried about using the drone to do things that are value add to their business.
Can you give us some examples of what are those details that people don't necessarily think about initially, but they do come across them when they're trying to operationalize docks? Backhaul connectivity infrastructure is one of those things, but what about integrations with their own systems and some other elements?
Well, sure. As we mentioned, right, sometimes it's the simple things like I would like to put the dock here or multiple docks in a location on a facility. You sort of need a clear area. You don't want people approaching it. So you need to put it in the right spot, and then you need to have power and connectivity to that spot. And all those are things that take some prep time and have to be planned for. So, but I think that's all, those are friction points, but they're solvable. And as I mentioned, we help with that. I think in terms of what do you do with the data when you get it, that's sort of always a problem for drones, right? Those integrations with systems, I think, are just part of the sort of the data transformation of doing work with drones. So the drone takes a video, the drone takes a picture. What do I do with it now? Where does it go? Where does it live? Is it processed by analytics? How long is it retained? Those are real issues for businesses, and I think, as a drone manufacturer, we try to do what we do at Skydio to provide APIs and things that make integrations as straightforward as possible. We have certain partnerships, but this is, it's not unique to drone in a box. I think what might be slightly unique is if at scale with a lot of drones flying routinely, it's a high volume of data. It's a lot of data that has to be moved and then potentially stored. And I think a future state is one where we're not really necessarily storing all of that raw imagery and video, but it's being processed maybe even at the edge, and the information that we're interested in is what we retain and not necessarily all of that raw data.
So Jen, how do you see the value chain shaking out then as the drone in the box concept matures? You have the hardware providers, and there are pretty good arguments why the drone and the dock are going to be sold together because they work together so intimately. But downstream from that, technologically, how far does the software from that dock provider go in meeting these needs? What will be the role of system integrators in the future? And then what will end users expect in terms of how they interact with these new networks of docks that are in their enterprise? How is that going to shake out in terms of integration, software, and the services that allow it to scale, in your mind?
Well, I think my experience is that enterprises want to use drones as a tool. Organizations want to use drones as a tool, as a way to get actionable data, to get information. And the aviation part, the infrastructure part, the software integration part is all stuff that has to happen in order to get at that end value. But it's really hard for organizations to just take all that on. I think very few can do it. And that's why I think drone as a service in some form or another is going to be very, very popular. I don't think it's going to be ubiquitous. I think there will always be organizations that want to take this on internally, that they staff up to do it, they take it on and they run their own. And they can be system integrators in and of themselves. They can put all the pieces together internally and run their program. But I just don't think that's going to be very common. And I think choosing to go with, an external provider of an end-to-end service versus building something internally kind of will bounce with the normal business cycles of how that plays out with contracted services in general. But I think it's complicated. And putting all of the pieces together and having them be robust and work routinely and deliver all that value and continue. So, the maintenance of it, the upkeep of it, integration with new services as they're needed, as things change in a business, as needs change. I think there's always going to be a need for that to happen. So for someone with a lot of technical knowledge to come in and help businesses and organizations use drones most efficiently and effectively. I think, from like Skydio's approach is to mostly be the one-stop shop for that. I think others will take a different approach, and we'll just have to see, what end customers prefer to do.
One of the things you point out is that a drone in an enterprise or an organization is a new concept. It's a concept that a lot of the people in those customer organizations just aren't familiar with yet. And everybody is in an exploration phase to figure out, well, how can we really make this thing work? How can we make it deliver value? And then derived from that will be the contours of the software and the product that delivers that value. And so it's in such a state of flux that it seems like there is a lot of opportunity for the software and the integration services to evolve pretty fast right now.
Yeah, I think we could separate these things a little bit, right? There's flying the drone safely. So all the pieces that have to do with, the drone, the associated elements, the connectivity and backhaul and C2 and power and everything that takes care of the drone itself and how it's operated. And then there's the data piece on the other side. So the fleet management piece, maybe the integrations with analytics solutions, archiving, and maybe even requesting services or dispatching the drone, right? Maybe there's integrations associated with that. So it is an ecosystem. I don't think it'll ever be like completely vertical, just because like doing the analytics piece on data, right, is a project and an engineering task unto itself, and it can be highly specialized. But things like fleet management, for example, that's kind of baked into cloud services around deploying the drone anyway. And so maybe that's something that's always associated with the OEM, but then analytics and what you do with the data downstream is part of an ecosystem of partnerships and integrations.
So you mentioned automation, you mentioned safety. I think that deserves a double click. So maybe we can start with automation. Autonomy versus highly automated. Where on the spectrum do docs currently sit? But before that, how do you define those terms?
Right. In my mind, what unlocks scale for the industry is autonomy. And in my mind, it's not really technology that's holding us back on that. I think we can start right now in the right environments and situations. And I think in the right environments and situations, we can trust drones just like we trust any other industrial robot. And so what is autonomy? That's a great question. Autonomy can be a trigger word. It can also be used rather interchangeably with highly automated. And distinctions seem to revolve around whether or not a human can intervene in the operation. I recently saw a slide from the FAA Beyond 2 program offering that autonomy means no possibility of operator intervention. And that aligns with the ARC report recommendation. There's a table in there that talks about AFR levels, or automated flight rules levels, where level 4 is human out of the loop with no possibility of human intervention, and AFR3 is human over the loop, also called fully or highly automated, where human intervention is possible but not required. And if that's how we're going to define it, then great. There's plenty of room for expansion and innovation with highly automated systems. So if operator intervention only boils down to a big red stop button, I think it's kind of a distinction without a difference. And again, it's a good thing as long as we remember that we don't over tilt on the safety benefit of direct human oversight. So no matter what we call it, what I'm interested in is unleashing certain operations from real-time direct supervision by a remote pilot or trained operator. And to be a little provocative, I call this like 0 to many.
So, Jenn, give us a practical example of autonomy versus highly automated.
Yeah, I guess what I'm saying is that autonomy, by the definition of no human can intervene with the system, I don't see anybody building anything like that, practically speaking, in the near term at all. But if we're going to call autonomy and highly automated a system that can handle contingencies, that can respond to alerts, can follow pre-programmed flight plans, can automatically assess the weather and know whether it should take off or not, with very little, if any, direct human oversight in real time versus pre-planning, I think there's plenty of use cases which could benefit from kind of a set up a operation, vet and validate that it works, and then let it run routinely to collect data over time in a consistent manner. So no matter what we call it, I think there's a need for that, and I think there's the technologies in place to allow that to happen without a person sitting in front of a GCS screen and monitoring the flight from beginning to end in the sense of what we might think of as a piloted operation.
Yeah, that does seem like an interesting definition of autonomy. And if it does boil down to just hitting a big red stop button, then yes, I agree. The difference between automation and autonomy becomes fairly trivial. Do you know the background for why this definition was crafted in that way?
I mean, it certainly was in the ARC report. It was a discussion of a subgroup in the ARC. And I think, maybe it's just the perspective of, we shouldn't allow autonomy to be a word choice that holds us back from taking advantage of all the things that drones can safely do today. And so maybe we put that goalpost way out there knowing that, we're not going to be there and we don't need to worry about fighting over that definition. Let's take advantage of the space we have to use highly automated systems in a safe way.
Jenn, tell me if I heard you right, that you feel that there's going to be a lot of opportunities unleashed with autonomous operations. Talk a little bit more about that. What's not being realized today, and what do you mean by, great opportunities unleashed? Be a little more specific if you could.
Well, I think if you ask most people, what does a drone operation look like? A BVLOS operation. What does a BVLOS operation look like? What they think of is a pilot sitting in front of a GCS monitoring a flight happening. Like maybe the planning of the waypoint-based flight plan happened prior to takeoff. It was loaded into the aircraft. The aircraft takes off and is flying this mission, but the pilot is still there watching the flight happen, and they're present in real time during the flight. And if you think about multi-drone or multi-site operations where there could be more than one drone in the air in one flight operations area, or different operations areas distributed geographically with one pilot monitoring those, with flights happening concurrently, like maybe that GCS configuration looks different. Maybe it looks more like air traffic control than it does a flight deck. But I think the impression most people have is that a person is sitting in front of a bank of computer screens watching flights happen. And while I think there's always going to be use cases that require that, principally when there's real-time action that could be needed, a response in real time is generally going to be required or beneficial to the use case, then you need to sit there and be present and have direct supervision. But for a lot of industrial point inspection or mapping and surveying types of operations that could be happening on a routine basis at the same place over and over again, I think our technology is at the point where we probably don't need a person to sit there and monitor that flight. So if you're a big enterprise and you want to invest in a remote operations center and have a bunch of pilots on staff and run these operations, Florida Power and Light's a good example of an organization that's invested in that kind of a concept. There's nothing wrong with that. It's great. But I think there are smaller enterprises or different enterprise use cases where, you don't want to do that, and there's maybe no safety benefit to sitting there monitoring the flight. What if you had a person who's responsible for that drone operation, but they're not sitting there watching the flight happen? Maybe they're getting updates on their phone from the system. Maybe they're being alerted when something off nominal is happening. Maybe they need to go and validate. The drone system maybe isn't sure that the weather is good enough, so the responsible person gets notified, checks the system, says, no, I think it's good, go ahead and do the flight. Or no, it's not good enough, cancel the flight. Or during the flight, there's an issue. The drone did not land in the box for some reason. There was contingency behavior. The drone is now at a safe landing point on the facility and needs to be retrieved. And so the system tells the responsible person that information, and they go deal with the situation. I think that's a different operating concept than what most people think of. It is to be, able to interact with the system and intervene, but it is not sitting there in front of a GCS directly operating the drone.
Okay, so this is an interesting distinction because I initially thought your definition of zero to many, which I haven't heard before and I like it, is no human involvement. And it really echoes the definition of autonomy where there's no way for the human to intervene. But what you're actually describing is a different kind of UI that moves away from a person sitting in front of a bank of screens and watching fleets of drones do their thing, but instead having a different way to interact with that operation, with those robotic systems in a way that makes it easy to do so with large numbers of drones in the air, but at the same time addresses perhaps some of the safety concerns that you have with existing one-to-many setups. Is that where you're going with the conversation?
Well, what I'm saying is that I hear a lot of people focused on one-to-many operations and the user interactions, the human interface aspects of it, that the design that leans more to area operations or area control or more like an air traffic control system. And those are all fine. What I'm proposing is that there are operations that can be done safely without having the interaction model be even that. It doesn't have to be a flight deck model. It doesn't have to be an air traffic control model. You're relying on the autonomy anyway. Like, if the only thing that the supervisor can do in a large-scale one-to-many operation is maybe draw a circle around a bunch of drones and have them land, or land all drones, or return home all drones, that's very minimal interaction. That means that autonomy, or the highly automated system, is handling nearly all of the nominal functions and the contingencies. The human is just very much a last line of defense, and you're likely trying to achieve a state where that person really never does anything. I think what I'm saying is that there are low-risk environments and low-risk operations where I think we already are in a position to do that operation without that direct real-time supervision. So we're not sacrificing safety. We can do it safely because all that automation capability is already there, and having a person sit there and watch it doesn't really add anything. So why can't we just enable those types of operations, which would allow a variety of enterprises to very efficiently use drones, because maybe they're going to have a responsible person who's fully trained, who can manage the drones, who can set up the flights, who can validate the flights, and who is responsible to monitor them. But that is not their only job. They can go do other things and attend to other issues, or maybe deal with what information the drone is providing them, and their full-time everyday job isn't sitting in front of the screen managing the drones. I think that makes it more appealing to enterprises who want to use drones as a tool and not invest in an full-up aviation program.
You mentioned already a few hints as to what this new UI might look like, but do you mind going in a bit more detail as to what your vision of this human-machine interface user experience might look like in the future?
Right. Well, I don't think the future is too far away. I mean, I think you should always be able to like pull up a GCS and get to a drone and commandeer it from its pre-programmed mission or however it's being currently guided and, commandeer that drone and fly it. But you probably aren't going to have to. So if we go back to that ARC report AFR level 3, it said human interaction is possible, but probably not required. That's what we're trying to achieve, where the system is performing, it's handling itself, and we very infrequently need to even interact with it while it's flying. Now, that doesn't mean we don't need all the same tools to set up the flight, provide the settings, define a geofence, define a plan, a volume of operation, and all the other contingency settings that we might need. Where are the safe landing zones within my operation area? The drone is still going to need to know all of that stuff a priori. But then once for example, imagine it's just a scheduling function. Like, what if your UI was just scheduler? So most people who interact with the drone are like dispatching the drone to collect information on a schedule. The person who touches the drone from an aviation safety perspective is somebody who can vet all the settings and configurations for the system. But the end user of the drone in the enterprise is asking for data. And so they might schedule an operation and they want the data at the end of that flight. So maybe all they see is a scheduling tool and then a data repository or a data pipeline they get their information from. Maybe the responsible person who's trained in the drone system, maybe they have a simplified phone app that issues alerts and warnings to them or statuses that they can pull out and look at any time. And if they want to, they can click into a GCS for any of the drones that are operating if they really, really had to. Or they could run back to their office and do that if they need to interact with the drone at that level. But our end goal is to really make that a very infrequent thing, that you wouldn't most of the time ever need to do that. And again, I don't think this is very far away. I think this is stuff that we could do now and that we should start exploring in the lowest risk environments.
And in the one-to-many concept of operations, when it comes to safety and automation, are you concerned more about the automation of the drone itself or the risk that is inherent in that remote operator or the user interface?
I guess what I would say is that if we think that it's safe for one person to monitor 30, 50, 100 drone operations, what we're really saying is that the drone is safe. So highly automated that it's taking care of itself, right? Like, we don't have an air traffic controller call up a pilot and start telling them how to move the control sticks, right? There's a certain level of interaction there that the air traffic controller would expect the aircraft to be able to comply with instructions in an accurate way. And they're not worried about that happening. That's the level that we're at and we have to be at, where the drone is handling itself, right? It can go land in a safe place, whether that's back at its docking station or in a designated area that's safe to land in. It can avoid obstacles. It can avoid air traffic. It knows how to handle low battery or loss of connectivity situations gracefully. And we don't really need to intervene. So if it's repetitive, if it's routine, the same flight is going to happen almost every time with very little variation. And when something off nominal happens, it's handled. We have to expect that, or else one human can't manage 100 drones. It's not feasible. If you were to have multiple concurrent failures, right, then definitely the drones have to be able to handle themselves and not run into each other if it's more than one drone in one area. So all I'm trying to say is that in order to get to a one-to-many operation with a human being is like the big red stop button. Like, we already have a high level of automation, and in some very constrained environments, we're probably never going to hit the stop button anyway. So why don't we go and try to let those operations run?
And Jen, what are your thoughts on the recent FAA waivers of 1 to 20, 1 to 30 type approvals for certain drone delivery operations?
I think that's just a great example of what I'm referring to. Those drones are mostly, taking care of themselves. They're flying the route, they're making the delivery, they're coming back. From what I've seen, there's a person monitoring those operations. And I think that's valid, right? That's a higher risk environment, flying over a community even though I know some of those routes are basically designed to minimize ground risk, right? And that's great. There's still a person watching in real time. I think this goes back to the idea that the word pilot's used 6,000 times at least in the CFR. Our whole paradigm of aviation is based on the pilot's responsibility for flying. And it's not like we're saying that the pilot is no longer responsible. It's when is the pilot responsible. For a lot of, routine inspection operations, for example, you still need someone who's qualified and trained and understands the system well, understands, risk and hazards, and knows how to do flight planning, knows how to set up the system contingencies to fly safely and complete the mission end to end. But that stuff happens before the aircraft ever takes off, for the most part. And when you get to the pre-flight actions of, am I meeting weather minimums? Are the operating limitations going to be adhered to? There's still a way to automate all of that. So once the constraints of the operation are set up by a qualified person, I think we're at a point where, again, in low-risk environments, the operation can be set up and it can run. And the goal of any operation is to mitigate all of the reasonable ground and air risks to an acceptable level. And if you can do that through all of your automation, then you're safe enough. And you don't necessarily need to be watching the drone do it.
Jen, what level of autonomy will be permitted under the upcoming Part 108?
I think everything we're talking about will be permitted. I think maybe there's going to be a little bit of I think what I'm talking about with 0 to many is going to take some thinking. Like, is this really within our vision of what can be done? And I think there's going to be room for it. I also think there are going to be human oversight of a large ratio of drones as well. So I don't think it's going to be one or the other. And again, I think there's a risk continuum here. But if you look at those ARC recommendations, right, the AFR level 3 is what I'm talking about. It's pilot over the loop. We're not talking about when the pilot is over the loop. In my concept, it's really before the flight and after the flight, not necessarily during the flight, although it could be, right? So pilot intervention is possible, but not necessarily required. And if the proposed rule follows the recommendations, I think this will open the door to this. And I think it could be a great benefit to a variety of our customers, certainly with drone-in-a-box solutions, where the whole point is to have this distributed, remotely positioned drone be able to do things that you don't want a person to have to be on site to do. And if you trust it enough, which I think we can, you may not need to sit there and watch the operation happen. You're just going to get the data at the end of the day, which is what you want.
And in order to make 0 to many a near-term reality, how do you anticipate ground and air risk being handled? What needs to be done there? And also, how do you build the trust of the end user that they can somehow relinquish control and fully trust these drones to do their job without a human sitting in front of a bunch of screens?
Yeah, that's a great question. That's a key question. Like, the tech can do it, but will people trust that it can be done? Because, if you're responsible for a drone program and the drone goes off and does things that you didn't think it was going to do, that's never good for the longevity of your drone program. So trust is key. What needs to happen for this to be done safely? Well, I mentioned a few of these things, but you need a system that can automate the pre-flight system checks and pre-flight actions for compliance, as I said, with things like weather minimums. So you shouldn't take off in freezing fog, for example. You have to meet those requirements. The system has to know how to do that. Now, there's a variety of ways to do that. You could use a variety of weather sensors and whatnot, as well as the camera systems on the dock and on the drone to assess that, make a decision, a go, no-go decision. You could have a person do that piece of it and check those sensors, make a decision, and then authorize a flight. I think both are possible and they're not mutually exclusive, but I think we're at the point where we could fully automate that. So the drone is sitting there, it's scheduled to do a flight, it checks the weather, it checks its surroundings, it checks its own subsystems, it's in a condition for safe flight, and the environment is appropriate, there are no hazards in the area, I'm safe to take off. So you need that. You need containment, in my opinion, of your route or area. So you want some sort of constraints around where the drone's going to fly, so you don't have a flyaway. It's a common thing everybody is concerned about. And containment addresses that, so think of that as a geofence. You then might want to define contingencies for your operation area. So I mentioned earlier, where is a safe place to land if I can't get back to my dock or my drone box? It can happen, right? It could be battery performance or things of that nature where the system decides it would be safer if I go to this nearby landing zone that is away from people or sensitive equipment, and I'm just going to go land there. You need automated contingency behaviors. Landing in that safe place is one, but when do I curtail the mission? It's safer to curtail the mission and go back to the dock. So like lots of link issues perhaps, or battery performance. So you want to gracefully handle those things so that, a remotely located piece of infrastructure like a drone in a box, it's very much not ideal to have to go to that remote location and put that drone back in the box because it didn't land there. So you want that to be a pretty rare event. So you want that drone to come back to the box under most off-nominal events. You need either very precise flight planning, or you need good flight planning, and also obstacle avoidance is a safer thing. So there's a pole, there's a new piece of equipment, a drone that can navigate around that obstruction gracefully and keep going on course is ideal versus one that, well, now there's an obstruction between this waypoint and that waypoint, I'm just going to smack into it. That's not ideal. So obstacle avoidance for static, ground obstacles and structures and of that nature adds safety. And then, of course, you need the air traffic awareness and the automated avoidance. So if you're not going to have a human on site, then, obviously at Skydio we're big fans of shielding because we do have that obstacle avoidance. And shielding means that you're just highly unlikely to have to do an avoidance maneuver. But if you have to do it, we're a multi-copter, so we do the safe state maneuver, which is a descent. We can also get really, really close to an obstacle such that, we're sort of part of the obstacle then. And if an airplane is going to hit the drone, it's going to hit the obstacle as well. So those kinds of avoidance maneuvers have to be automated. And if there are more than one drone operating in the operating area, the drones can't hit each other either. So you can't hit a manned aircraft, you can't hit another UA. And so if they're all Skydio drones, they can all talk to each other and not hit each other. When you put all those things together and then you put it in a constrained environment, like say an electrical substation where the ground risk is mitigated, there's a big fence around it, there's infrastructure there, the substation structure itself, which, if I'm in an airplane, I don't want to be anywhere near that. So I think that's like an example where, routine monitoring and security patrol with a drone in a box solution is really great. It's really low risk from the aviation perspective, and it can be highly automated, and I don't necessarily think a person needs to sit there and watch it fly.
All right. Let's say hypothetically, there's an upcoming football game between, say, Penn State and, let's say, Notre Dame. And you're in the audience, you're in the stands with somebody, and somebody turns to you and says, "What do you do at Skydio?" What would you tell them?
I could tell you what I was told my job was when I was hired was unlock the dock. That's what I do at Skydio.
Nice. How has the industry changed the most since you've joined? And what's been the biggest surprise?
I think the biggest thing that changed, and it may have happened slightly before 2021, but not too much prior, was when I first got into drones, it was all defense. Defense. There was no civil market or industry really to speak of. There were hobbyists, maybe a little bit of camera drone stuff happening. And then there seemed to be like a huge upswing in civil commercial operations and solutions aimed at enterprises, while also like the consumer industry was developing as well, and there was focus there too. And now I feel like we're coming around again back to defense. And I think there's a lot of reasons for that you might not be able to have predicted back in 2021 that would happen again. But I think that's what I've seen. It's like defense, then civil commercial, and now maybe we're headed back to a time where defense is more interesting.
Let's see if we're still in the stands here. Let's say from an investment standpoint, is it more or less attractive on the commercial side and on the military side from 4 years ago? How has the market expanded or contracted? And from an investor standpoint, has it been more or less exciting on the commercial and military, in your opinion?
Yeah, well, I think Ukraine has brought a lot of attention to drones and defense tech in general. and the opportunities that exist there. Civil commercial is hard. Regulated industries are hard. There's uncertainty on the regulatory side. Things that people thought would happen quickly did not. If you look back 5 years ago, people trying to do UTM presented themselves as fleet management, and then maybe they just couldn't hang on long enough to see things come to fruition. And so we see these cycles happen where, because you don't know how long it's going to take to have sort of the regulatory certainty, it's just really hard to hang on. I think defense is always interesting from the perspective that your customer hands you requirements and money for usually, for the most part. It's not always true, but generally speaking, the way it works is they have requirements that they tell you about, and they hand you money and you deliver a solution. And that's great. That's attractive. You know what you're doing, you know what money you have, and there's a chance for longevity of the program if it meets most of its objectives, and there's a real need. On the commercial side, it's always hard to find that product market fit that gets you the scale of business that you need to continue to grow and thrive and survive. On the enterprise side, there are a lot of, well, I want this specialty solution, or I can't buy it unless it does exactly this. And it's hard to build it first and then get it paid for later at risk. So I think those are the trade-offs. And I would say that civil commercial is challenging on a lot of fronts.
Yeah, you're cautious on that civil commercial side, aren't you? You're saying it ain't easy, but you anticipated the same 4 years ago, and you're saying it's the same today.
Yeah, I mean, so to be clear, drones are useful. And I've been involved with it for more than 10 years now, but in many ways it still feels like it's early, especially for certain systems and use cases. Like, the potential is there. I think the potential is going to be realized, but it's the timelines that we're always out on a limb if we're trying to predict. 5, 6, 7 years ago, when I was flying a big drone around every day, I thought, well, BVLOS is here. We solved it. It's done. But drones are not a solved problem. And I think Part 108, when we get it, is going to be extremely helpful. I think if it turns out the way we all want it to and expect it to, it'll be slightly harder for manufacturers because there's going to be technical requirements and means of compliance you're going to have to meet. You're going to have to show your homework. It's not going to be the Part 107, build whatever you want, see if people will buy it. There's going to be a technical standard to meet and reliability. It'll probably drive up costs a little bit. On the operator side, it's going to be a little bit easier. You won't have to write this magical waiver to be able to fly in a way that helps you do things efficiently in the way that you need to collect your data or complete your mission. So I think good things are around the corner. I think there's going to be a drone industry. I just don't know how many participants can play in the space. There's always sensors and payloads. There's also always software that deals with the data. But in terms of building drones themselves, I think it's going to be hot competition for the near future.
Jenn, what do you think unlocks the civil commercial market? Often we hear regulation being thrown out as one of the reasons that the industry is being held back, and to a certain extent that is true, but at the same time, I feel like that might be an excuse that people are using because, you've been personally directly involved in some really key waivers and exemptions that have paved the way and set the precedent for other organizations to mimic. So I'm thinking that the regulatory flag is a bit of a red herring. In your opinion, what will unlock this segment of the market? Is it zero too many? Is it drone boxes? Is it a continuing descent on the cost curve?
I'm a good aviator, so my answers are always, it depends, but maybe more like all of the above. I think all of those things are factors, right? I tend to agree with you that sometimes regulatory is used as an excuse, but maybe it's like a good excuse, right? Because what I've seen in enterprises tends to be, prove to me that there won't be a barrier to me. Like, if I buy this technology and I really like it, and it provides great value, prove to me that I'm not going to run up against a barrier. So I can run a POC. Let's use an example, right? Just hypothetical example. A POC in a handful of electrical substations for dock drones. But prove to me I could put this in 1,000 of them, that I'm not going to run up against all these special conditions like well, I can't put this one here because it's near an airport or it's in controlled airspace or it's in a populated area. It's completely cordoned off, it's ground controlled area, but it happens to be in this populated area. Is that going to impact me, right? Tell me there aren't barriers to my adoption, and then I will feel better about putting money and my capital towards this technology. So it's an excuse maybe, but it's also valid that enterprises don't want to allocate money to big programs if they feel that it's going to be super complicated and they're going to run into a lot of barriers. So I appreciate that, and I've done a lot of work over the years trying to keep knocking those, if we want to call them barriers, knock them down or pave the way so that isn't going to stop somebody from taking a shot at using drones to solve their problems. I think cost is interesting because obviously, what are you comparing it to? What is the cost of a drone being compared to? In certain kinds of inspection operations that I'm familiar with, the comparison was up against a manned helicopter operation. That looks different than comparing a dock drone solution to a BVLOS drone operation with a person in a truck roll. And that looks different than a person without a drone with other pieces of equipment in a truck roll. Or not having the information at all and suffering a failure of a system or an outage or some other costly event. So I think that everybody wants technology for as low cost as they can get it, but I think it's just hard for us who've been in it a long time to see how early it is and how drones aren't that well understood and readily, instantly adopted yet by all manner of enterprises like they could, and I think they will be. And I do think that drone-in-a-box solutions, automation, highly automated systems, one-to-many and zero-to-many operations are the kinds of efficiencies that will play into an ever-increasing adoption. We just have to all hang on until we get there. And I think regulatory frameworks in place will help. It's certainly not going to hurt, I don't think.
When you talk to end users, what are some of the more common objections? You mentioned this fear of constant engagement with waivers and exemptions and this regulatory uncertainty. What other pushback have you heard from end users?
One thing, I don't know if it's pushback, but I think we have an opportunity in some places to keep the drone in use, right? The drone's not in a place to do one job, every once in a while. Right, so in use cases and locations where a dock drone solution can be used by multiple different groups within an enterprise or in partnership across different enterprises as a co-located piece of infrastructure that helps different groups or different organizations or different groups within an organization so that infrastructure, that drone is being used all the time, I think that makes the cost look better. And I think there's a huge opportunity for that, right? And drone as first responder, locating dock drones in cities, and then showing what could be done with those drones from a smart city perspective, I think that'll be very instructive. I think people figure out what to do with the drone when they have it at their disposal, and people come up with some really creative things. So I think it's always better to have the drone be in use as much as it can be, so its duty cycle is high, and it's not just something that is, if it's going to be parked somewhere and only used once in a while, then that use case, that piece of data that it's there for to address has to be super high value for it to win its value proposition. So I think maybe one thing I expect to see is people figuring out ways of sharing infrastructure, sharing drone-in-a-box solutions, and flying them very routinely to get that cost value to line up.
Jen, what do you see the market in the next 5 to 10 years? What are going to be the most dramatic changes?
Well, maybe sooner than 5 years. I think drone as first responder is really seeing a lot of adoption right now, and I think that's going to continue. And I think there's going to be a lot of value from that, and then continued adoption in the enterprise space.
Give specifics of the first responder. Why are you excited, and who's going to pay for it?
Yeah, I mean, I think agencies have funding for this. We're seeing major metros really adopt it. They're getting, what value do you place on de-escalating a situation and keeping people safe, right? It's hard to do ROI on keeping somebody alive, right? So the safety aspect of it, I think, is just super clear. right? When everybody's got more information about what is happening, then everybody can make a better decision about how to deal with it. So we're seeing a lot of interest in that, and I think that's going to continue. And it's perfect drone in a box type of application. Drones are on the roof of precincts and deployed out in direct response to a 911 call. So they're not just out there looking for anything. They're responding to a call, and they're eyes in the sky to help improve situation awareness.
Great. Anything else in the next 10 years?
Well, I mean, on a personal front, I think if Part 108, if the proposed rule includes what was proposed in the ARC recommendations. I mentioned earlier that flying a big drone hundreds of miles for long linear felt like very, very much too early in the 2015 to 2018 timeframe. And hopefully with these rules that sort of allow for this now, should we see the proposed rule come out in alignment with the recommendations, I think we'll see some bigger drones out there doing those types of operations, like maybe some cargo or maybe long linear inspection. And I think that'll be exciting to see not only small drones out there doing work every day, highly automated, but also larger ones as well, serving different needs that have been sort of shelved for a little while.
You've probably been asked 100 times in the last couple of weeks about what the heck is going on in New Jersey. What's the biggest misunderstanding of what's going on in New Jersey, being the expert that you are?
I was going to joke and say that I've been busy in New Jersey flying a lot of drones this past month.
Right.
But no, I guess something that I've been a little disappointed about is I think people in the drone industry have tried to fill this gap on LinkedIn and things, but I think nationally I haven't heard as much commentary saying that there are a lot of legal drone operations and at night with lights on, right? There are drones out there doing work every day. I can't speak to what is, the details of everything that's going on out there in New Jersey, but people should know that the sight of a drone is not cause for alarm, that the sight of a drone, even at night, the lights are on purpose. And if you're seeing what you really think is a drone, that it could be completely legal to be flying where it's flying. Don't think nefarious intent like right away. I think the other thing that's shocking is that people don't know what airplanes look like in the sky at night. So now there's more attention drawn to that, and hopefully people will come out of this a little more educated. I hope. We'll see.
What advice would you give to somebody, an entrepreneur or a business person in the drone market?
Yeah, drones are hard. People always say that drones are hard because they are. But I think from where I sit, what I remind people of is that it's a regulated industry. And as frameworks evolve, as technical standards evolve, it's only going to get harder in a way, right? You have to know up front, right? Your tech can be really cool and really awesome, but you need to have your eyes open going in as to whether you're going to have any aviation regulatory issues with what you're trying to do. I gave a talk to a group that was in an incubator working on tech, talking to them about how they had to pay attention to aviation regulations and be mindful as they're developing their technology if they're going to have any roadblocks they need to overcome, or if they're going to have any technical standards they're going to need to meet that they're not planning for right away. Because planning for that out front is very different than being surprised about it later on. And their eyes were a little bit glazed over. So I think this is something that will come with the maturity of the industry, and it's just a part of the evolutionary process of being a new entrant in an established industry like aviation. But I think that if you've got some cool tech, you want to build a new thing, just be sure that you know where it fits in the sort of the regulatory frameworks and what you might have to do to actually deploy your awesome tech.
All right, given we're talking predictions and I'm still in the stands, what's the final? So Jenn is a Penn State grad. What's the final score of the upcoming game? So it's Notre Dame, Penn State. This will be published after the game. So what's the final score?
Oh man, I'm usually pretty good at picking winners, but
Can we
I'm
say
not.
You're going to pick Penn State?
But I'm not great at predicting scores. So,
All right.
and I haven't seen Notre Dame play this year. But I'm going to say that Penn State's going to win by less than a touchdown.
All right, cool. Is there anything you'd like to leave with our audience? One message you'd like to leave with them before we end?
I think it's important to remember that in many ways it's still early days for drones. I mentioned a few times earlier that if you've been in it for a while, it doesn't feel like that, but it's really true. And I don't think this technology it's not going away. We're still learning how to bring it to market and how to find product market fit and how to make it efficient and effective. And tech is evolving, but I think the sky's the limit for drones and their use to benefit society. And I'm super excited to be working on it and continue to work on it for years to come.
What a great way to end the podcast. Thank you very much for the conversation. It was really insightful and really enjoyed it.
Thanks for the opportunity. Really appreciate it.
All right, that's a wrap for today. Thank you for listening to the Vertical Space Podcast. Reach out if there are topics that you would like us to discuss, and goodbye until the next episode. Unless mentioned, this podcast is in no way endorsing or promoting any person and/or company mentioned, and all opinions within the podcast are solely that of the presenters. The Vertical Space makes no guarantees, warranty, or representation of any information given in this podcast. Any information given is for informational purposes and should be used at your own risk. This podcast is for general, educational, and entertainment purposes only.